Welcome to the Harris County Flood Control District's second public meeting for the Cedar Bayou Flood Risk Reduction Study. This video will provide you with a study update regarding the progress to date. The study team, comprised of civil engineers, hydrologists, and environmental scientists, are working together to develop a feasible, long-term flood risk reduction plan for the Cedar Bayou watershed. The Cedar Bayou study will include the main stem of Cedar Bayou, as well as 18 tributaries in Harris County, which account for approximately 90 miles of channels. The study was made possible in 2016 when the Harris County Flood Control District received a flood protection planning grant from the Texas Water Development Board. The flood protection planning grant for Cedar Bayou includes three components: generating a watershed-specific flood protection plan, potentially enhancing the flood warning system, and updating the Flood Control District's hazard mitigation plan. The grant has enabled the Flood Control District to update the hydraulics and hydrology models for Cedar Bayou so that the project team can better understand how stormwater moves through Cedar Bayou and its tributaries. This provides a baseline of existing conditions that enables the engineers to determine the efficiency of the bayou's stormwater carrying capacity and where improvements might be needed. Next, the project team will evaluate potential flood reduction projects for the main stem and tributaries included in the study. Finally, this information can be used by neighboring Liberty and Chambers counties for effective stormwater management planning. The study is expected to be completed in the spring of 2018. The purpose of the Cedar Bayou Flood Risk Reduction Study is to evaluate the existing risks caused by out-of-bank stream flooding and develop a plan to address those flood risks by identifying potential channel conveyance improvements and stormwater detention basins. The engineers started by updating the hydrologic and hydraulic models for the channels in the study so that they could better understand the behavior of the stormwater in the watershed. The update yielded a baseline model that shows existing conditions so that any planned improvements can be measured against this baseline. Hydrologic modeling, or rainfall runoff modeling, determines the relationship between rainfall and stormwater runoff in the Cedar Bayou watershed. For this study, we are evaluating the 10-year and 100-year design storm events, which is approximately 7.8 inches in a 24-hour period for the 10-year event, and 13.5 inches in a 24-hour period for a 100-year event. Hydraulic modeling uses information developed by the hydrologic modeling effort, as well as information about the channel and surrounding terrain to calculate how fast the water is flowing, the corresponding water surface elevation, and the area of inundation if the water surface elevation exceeds the top of the channel banks. To add to the engineering baseline, the type of existing vegetation and channel conditions and right-of-way constraints were documented for each stream segment. This environmental baseline will enable us to determine whether there is an opportunity to improve the natural functions of segments that are lacking and to minimize disturbing those that have high value. We also developed an environmental resource database to identify potential wetlands at a planning level. The database is not intended to be a substitute for field identification of wetlands, but it can be used to identify areas where wetlands are most likely to be found. According to the United States Army Corps of Engineers and the United States Environmental Protection Agency, wetlands are those areas that are inundated or saturated by surface or groundwater at a frequency and duration sufficient to support vegetation typically adapted for life in wet soils. For the study, the team looked at the soils and vegetation along the channel corridors, as well as the natural drainage patterns in the area. to determine whether the right hydrologic conditions might exist for wetlands. The wetland identification process utilized multiple data sources to investigate these criteria. Based on these factors, the wetland potential in an area was scored ranging from low to high. The graphic identifies areas with moderate to high wetland potential in blue. The Environmental Resource Database also includes a general characterization of environmental conditions along the channel systems included in the study. Using the Environmental Resource Database, we can identify potential areas that might be well suited for a wetlands or channel mitigation bank. These areas could be specifically preserved to offset wetlands and channel disturbances in other areas resulting from flood control projects. The last environmental component considered while developing the baseline was an evaluation of the habitat and stream stability in the study area. As part of the study, a preliminary geomorphological assessment was performed to evaluate the streams and their interaction with the landscape around them. This is an important element of the study because we want to develop a strategy that will integrate flood control work with natural channel design. If we are able to incorporate natural channel features, we can reduce flooding risks while creating stable channels that promote our natural values and minimize future maintenance and repair costs. The findings of this assessment will be used as we move into developing potential flood reduction projects for the Cedar Bayou watershed. The Cedar Bayou watershed has a documented history of flooding dating back several decades. We have records from the 1940s and 1950s identifying the need for channel modifications. The three largest storms in the flood control district records for Cedar Bayou chronologically were the October 1994 storm, the Halloween 2015 storm, and most recently, Hurricane Harvey, which has the greatest recorded rainfall totals by a significant margin. Hurricane Harvey produced a rainfall event in excess of a 500-year storm in the Cedar Bayou watershed. Cedar Bayou can contain roughly a 2-year event along most of the channel. Please note that the Cedar Bayou study will evaluate potential projects to address both a 10-year level and a 100-year level of protection, and not a more infrequent or extreme rain event such as Harvey. In order to better organize the discussion, we are going to break the watershed down into 3 distinct areas to present our findings. These areas include the upper section from the headwaters downstream to US 90, the middle section from US 90 downstream to Interstate 10, and the lower section from Interstate 10 downstream to the mouth of Cedar Bayou at Galveston Bay. We will provide some general information about the main stem of Cedar Bayou and the 18 Harris County tributaries included in this study. The upper section runs from the very upstream end of Cedar Bayou in Liberty County to US 90 and includes portions of the Cedar Bayou main stem as well as several tributaries. This area is generally rural with a few industrial tracts and some residential areas. The terrain is very flat, and a majority of the known flooding instances are in the residential areas. The upper reaches of Cedar Bayou have been widened and/or deepened, as well as the 4 tributaries included in the study: Q128, Q130, Q134, and Q136. Along Cedar Bayou, the side slopes are generally stable with spots of eroded areas. There is minimal tree canopy over the bayou, which has led to the presence of standing water and aquatic vegetation in the channel bed. As you can see, the area estimated to become inundated during a 100-year event is very wide in most of the upper portion. The middle section of the study includes the portion of Cedar Bayou between US 90 and Interstate 10, as well as several tributaries, including those seen on the map. This portion of Cedar Bayou was dredged and channelized in the late 1940s and early 1950s, causing abandoned meanders along both sides of the channel. This area is also rural, with agricultural land. However, there is some significant industrial land use near I-10 and in Liberty County, specifically Mont Belvieu. Active downcutting or erosion into underlying silt or clay with exposed soil along lower banks is noticeable. The terrain is also relatively flat, and reported structure flooding is more scattered than in the upper section. As with the upper section, the area estimated to become inundated during a 100-year event is relatively wide and overwhelms the lower portion of many of the tributaries. As Cedar Bayou approaches I-10, the area of inundation becomes narrower as the channel becomes deeper. A particular area of concern is Clawson Ditch, Q122, an unnamed tributary, Q12202, and their associated tributaries. This area is primarily agricultural with some residential areas. These tributaries were evaluated together because they are an interconnected system with overflows between ditches, causing combined inundation of Q122 and Q12202 into one flooded area. The lower section includes the city of Baytown, so there is significant residential and industrial development in the area. There are some large open areas in Chambers County, and Cedar Bayou is naturally deeper and wider in this area, and the lower stretch below State Highway 146 is used for navigation. This lower section of Cedar Bayou transports high sediment loads and increased stormwater flows from upstream channelization that previously occurred. All of this reach of Cedar Bayou has maintained its original sinuosity. The channel has widened over time due to a combination of land subsidence and sea level rise. Private and corporate interests have introduced bulkheads and piers along many portions of the shoreline. Since the early 1970s, the center of the channel has been deepened to accommodate industrial barge traffic. The area estimated to become inundated during a 100-year event downstream of I-10 is significantly narrower than upstream, with stormwater generally contained within the banks of Cedar Bayou through this reach. Now that we have established the engineering and environmental baselines, the study will move forward to analyze potential flood risk reduction measures. To do this, the team will consider methods for conveying and storing stormwater, such as channel modifications or stormwater detention basins. Traditional approaches such as a grass-lined, trapezoidal-shaped channel cross-section will be considered, as well as alternative approaches that seek to balance flood risk reduction with environmental stewardship. For example, an alternative channel section may include a terraced cross-section with riparian plantings. The Flood Control District's general practice regarding environmental features is to minimize impacts and then mitigate if necessary. The Flood Control District also strives to incorporate water quality and environmental enhancements into flood control projects where practical, such as stormwater quality treatment wetlands within wet bottom detention basins and natural stable channel design features in sections of channel that are modified to increase the efficiency of stormwater conveyance. These recommendations for flood risk reduction measures will be shared at our third public meeting in the first quarter of 2018. 3 public meetings are planned to inform the public of the progress of our Cedar Bayou study. The first public meeting was held in May 2017, and general study information was shared both at the meeting and after the meeting on the Harris County Flood Control District's website. This meeting is the second of 3 and is being held in 2 locations. At these meetings, we are discussing the baseline or existing conditions, including where flooding occurs, as well as environmental resources located within the watershed. The final meeting, which will be held in early 2018, will focus on presenting the flood reduction recommendations and laying out a conceptual plan for future flood risk reduction projects. If you would like to participate in the study, we welcome your feedback through the use of a study comment form you received when you checked in. You can return the comment form tonight, fill out one online, or mail your form to the address listed on the comment form. Thank you for coming to learn more about the Cedar Bayou Flood Risk Reduction Study.